Okay, so part B of this investigation says where we will be investigating the optimal perimeter. So in this case, what we want to do is, what if you're given a fixed area? We want to get the optimal perimeter. In this case, we want to get the minimum perimeter for a given area. On the previous example, we were trying to get the maximum area for a given perimeter. Here's the opposite, the minimum perimeter for a fixed area. So just like before, I want you to draw this. It says for each rectangle show, calculate the area and perimeter. So I want you to draw these rectangles on your notes. Okay, you may want to pause the video, and then it says let's calculate the area for all of them and then the perimeter, right? So here, the area for this one would be, well, length times width, 18 times 2, that gives us 36 centimeters square. So let's just put it, I don't know, somewhere over here. Area equals 36 centimeters square. How about this one? 9 times 4 is what? 36 centimeters square. So that's the same. 6 times 6 is 36, and 12 times 3 is 36. So the area for all of these is the same. And guess what? That's the first question. What do you notice about all of the areas? That they're all the same. So let's just write down. Okay, but they also asked us to find out the perimeter for all of these. Well, let's find out the minimum perimeter. Which one has the shortest perimeter? So let's calculate the perimeter here. So here we have 18 plus 18, that's 36, plus another 2, 38, plus another 2, so this is 40 centimeters. So let's write P equals 40 centimeters, okay? Hope you guys can see that P. All right, here, 9, so 9 plus 9 is 18, plus another 4 is 22, plus another 4 is 26 centimeters. So, okay, 26 centimeters. How about here? 6 plus 6 is 12, plus another 6, 18, plus another 6. It's 24. So P equals 24 centimeters. Okay, let's just keep that number there in check. And this is 12 plus 12, that gives us 24, plus another 6, that's 30 centimeters. So P equals, and I don't have enough room, I don't want to squeeze it in, 30 centimeters. Okay, so far, hope you guys can see this 24 on your video. In fact, I'm going to make it, I'm just going to write it here. P equals 24 centimeters. Okay, so well, they asked us, that's question B. Which rectangle produces the smallest perimeter? And what do you know? Which rectangle? Once again, the one that is closest to a square produces the minimum perimeter. So let's write this down. Right? So it says the rectangle that is closest to a square produces the smallest perimeter, right? It's closest produces the smallest perimeter. Okay. Part C says if a rectangle has an area of 55 centimeters square, what dimensions will produce the smallest perimeter? So once again, we are given an area, let me fix this, we are given an area of 55 centimeters square. What dimensions will produce the smallest perimeter? So let's collect our data. It's equal to, the area is equal to 55 centimeters square. Now how do we get, let's make this square a little bit bigger than normal. If we know that the area is going to be 55 centimeters square, how do we get the side lengths? Right, well, if it's going to be closest to a square, what's going to happen is we're going to have to square root, because if we think about it, right, the formula for the area of a square, right, area of a square, it's equal to the side length is going to be S side length squared. Well, if we're going to solve for the side length, we're going to do the opposite operation. The opposite of squaring a number is taking the square root. So the square root of that answer, I hope you guys can see this. Yes, the square root. So the square root of the area, we have to square root the area to get the side length. So that's the same idea here, right? Let me write this down here in a more formal way. Square root the area. So the first step was, they give you the area, you want to find out the side length that is more optimal, that gives us the optimal perimeter. You square root the area. Square root the area. And of course, let's do that, right? So side length, I'm going to call it, let's call it S for side length is equal to the square root of the area, which is 55. And what's the answer for this? Put it in your calculator, and I'm getting 7.42 centimeters. So let's just have it as 7.4 up to one decimal place. Let's round it off there. And so that means that this over here, 7.4 centimeters and 7.4 centimeters, is what produces a rectangle with the smallest perimeter. So let's write this down. Therefore, a rectangle with dimensions length equals 7.42 centimeters and width 7.42 centimeters will produce the smallest perimeter. And our next question would be, why would you want to minimize the perimeter for a given area? Well, this is up to you, but you can imagine, right? You may want to save money. So given an area, you may want to save money on fencing. Okay, you may have other examples, but that's my answer. And just to wrap up, just some key ideas, which are these. Okay, write these down on your notes. So key ideas: to optimize a rectangular region, we maximize the area and minimize the perimeter. And a square always produces an optimal area and perimeter.